Good morning, ladies. Good morning, ladies and gentlemen. This is Mr. Chen, MCR3U, with a supplementary lesson on applications of sinusoidal functions. Hopefully you can hear me. I've decided to provide an extra worksheet that's related to lesson 4. Lesson 4 we'll talk more about it probably in another video or previous video, depending when you're seeing this. And I wanted to take a look at, first of all, of a particular Ferris Wheel problem. I've taken this actually from the 2008 Nelson 11 mathematics book, functions book. And let's just take a look at it. On the second page, there's actually a full solution, but I wanted to walk you through it and how to actually do it. And I also introduced a second question to try to see if you could understand what's going on with this whole unit of trigonometric functions of periodic phenomena. Here we go. A group of students is tracking a friend, John, who's riding a Ferris wheel. They know that John reaches the maximum height of 11 meters at 10 seconds, and then reaches the minimum height of 1 meter at 55 seconds. So a Ferris wheel is basically a big circle, doesn't speed up or just slow down. And obviously in math, we're just trying to answer this question. So question A, how can you develop the equation of a sinusoidal function that models John's height above the ground to determine his height at 78 seconds? Part B, using your equation, when does John reach a height of 3.2 meters? So first off, there's a lot of things going on, and we just basically need to find the equation of this sinusoidal function. Now on the second page, there is a solution, and they just use different variables than what we're used to seeing. Let's just make a recap of our notation that we usually use. For example, we have two forms that we actually can write. Y equals A sine B x minus C plus D. Now I'm going to use capital letters. Or Y equals A cosine B x minus C plus D. So probably a sketch would be helpful to find out what's going on. So a sketch would be helpful, and let's just draw it down here. Right, where we have time on the x-axis, height on meters on the y-axis. Now, it does say in the question, they know that John reaches the height of 11 meters at 10 seconds. Right? So we don't know where he's actually starting from, but we know 10 seconds. So maybe we're here, 10 seconds. Maximum height is 11. So that's what we have. And then this is not drawn to scale, but hopefully you understand what I'm trying to do. And then a minimum height of 1 second, or 55 seconds. So 10 meters, 10 seconds, 55 seconds, respectively. Right? That's all we seem to have. But we know this pattern has to be sinusoidal, right? So when is going to be the next maximum? When is that going to be? And obviously that's the maximum. Just to show you in blue, we know it's going to be something that looks like maybe like this kind of pattern. And I think some of you actually know what I'm doing. I think you know that the next maximum height is it's periodic. Excuse me. That has to be probably right about there. And that value is probably going to be 100. How did I do that really easy? Well, half the period represents this length. What is that value? 45 seconds. So to get another value that has to be the same length of also half period, this has to also be 45 seconds for a total of 90 seconds. So already, ladies and gentlemen, from our information, we know that the period is going to be 90 seconds for John to reach the next maximum. We could keep on doing it, but that's all we need to do because we have a graph, right? A sinusoidal function. Now, what else do we need? Well, I think a lot of you remember we need to find its amplitude, and we need to find the equation of the axis. We'll use D. You can also use EOA. And we have to kind of comprehend if there's any phase shift. So a lot of you already know the connection between our previous topic, which was just looking at transformations of sine graphs and cosine graphs and figuring out their equations. This is an application where we can try to predict things, right? And I wish we could draw a good sketch. If we could, at 70 seconds, we could just read off the graph and tell it is. But because we're doing this mathematically, we're going to be okay. Now, I think some of you already are understanding how to do a couple things right away. If the maximum is 11, the minimum is 1, you already know halfway that value, and again, I just drew it quickly, that's probably the height of 6 meters. So we already got that. Visually, you could either use the maximum or minimum, or you could look at it again, just by looking at your sketch. From that maximum to the equation of the axis, what's that value? Well, that's 5. So notice we haven't really chosen the phase shift, and the reason why is because there's a couple ways of doing this. Either thinking of this sinusoidal function as a sine graph or as a cosine graph. So think about it for a moment. Let's just sketch them out really quickly in ugly purple. The sine graph looks something, and I'll put it up here, hopefully we can fit this in. The sine graph looks something like that, right? Whereas the cosine graph looks like that. And so you only have really 2 choices. And I think most of you are understanding the whole point of why I stressed the cosine graph earlier in our previous lessons, is because the cosine graph starts at a maximum. And as you can tell, just to point an arrow here, this pattern of John's motion on the Ferris wheel, and again, we don't know where he started. Notice we don't know where actually on the time 0 where he started. All we know is at a friend. He was already on the ride. He was at the height, maybe waving to us as because we're part of the students. He's waving to us, and we realize, oh, 10 seconds has already elapsed. So it doesn't really matter what we need to worry about the h-intercept or the y-intercept. But I think you always understand that this needs to be a cosine graph that has shifted right by 10 seconds. So there you have it, ladies and gentlemen. We have all the piece of information to figure out our equation. Now, technically, because this is a real life question, you actually should be working in radians. But right now, just to stress it, and I'll make this in red so that we're okay, you can still leave it in degrees. And I'll explain why maybe in a future video. I don't have that luxury. And this might answer a couple of your classmates' questions that are asking me some of those extra questions that were written, is because technically you could read off the graph of what's happening. So I think everyone's okay that the amplitude is related to the vertical stretch, or the A value. The equation of the axis, or the vertical displacement, is related to D, the vertical transformation or the shift. S related to the horizontal shift or the phase shift that we talked about. So the only one that we have to do a calculation is 90 seconds. And that's related to B. So let's just do that calculation now. B is equal to, and I said to leave it in degrees, so 360 degrees divided by the period. which is 360 degrees divided by 90, and that's 4. So let's put all the information together now. I use y, but we really should be using h. So h is equal to 5 cosine 4 times, now we'll use x if that's okay, or we'll use t. T minus 10. Now why minus 10? Because subtraction means to shift right, plus 6. So this is our answer for question A, just like that. So far though, right? Because what we had to do is develop an equation first. But then now it becomes pretty straightforward. And again, just using yellow marker, 78 seconds. I don't know where 78 seconds is, but who cares? 78 seconds could be, I don't know, maybe here. So my sketch is not that great. It could be even closer. In fact, let's just correct this a little bit, just so that you understand the problem. If you're using graph paper, it's actually easier. Let me just erase that part. Because if you were to graph this, some students would say, it looks something more like that. And the equation of the axis, let's correct that one too. My eraser's not working. Still not working. And I just wanted to show you, ladies and gentlemen, the conundrum. So it looks like 78 seconds could be right at the equation of the axis. It could be. All right, so let's just walk through the math here. Hopefully it's okay that I'll use not yellow, but I'll use brown. So then now how do we use our equation? H equals 5 cosine 4. And what's that time? 78 seconds. Hopefully you can feel that, ladies and gentlemen. Minus, I just changed the color. Oh well. 6. And you do this in order of operations. So 5 times cosine 78 minus 10 is 68. 68 times 4 is 272. Let me just double check again. Plus 6. And this is probably your first time really using now the trig equation, because we haven't really been doing that in our class. We're only dealing with identities. So this is a trig equation. So I would recommend you do the cosine of 272 first. Again, make sure your calculator is in degrees. So cosine of 272, get an answer, times it by 5. And I'm just doing this slowly. Obviously, many of you skip this step. 0.174 plus 6. So basically, to answer this question, John is at a height of 6.17 meters. So it's really, really close to the equation of the axis at 78 seconds. Just to talk about really quickly before we get to question B, and I will move this up. So again, I stole this question really from the Nelson Levin functions book. And again, they walk you through it. They might just use a different letter. For example, they use A instead of our B value. And they use D instead of our C. So just be aware of that it's just a different notation. Okay. But notice the second part of the question that I'm asking, let's just pause up again. Using your equation, when does John reach a height of 3.2 meters? So this is not T or X. 3.2 meters is the height or the Y value. So let's just take a quick peek on how to do this. Again, make sure your calculator is in degrees. We'll still do that in degrees. And I'll show you how to do this one. Again, if we could read off the graph, now let's just take pink if that's okay. 3.2, it's hard to me to do that here, but 3.2, it's there and there. So notice there's two possible answers. Let's just try to get one of them. And maybe some of you could problem solve the second one. So what does this mean? So let's just write the equation out again. H equals 5 cosine 4 times t minus 10 plus 6. And we're trying to solve for t when h equals 3.2. So sub that in. And don't feel bad. This is very uncomfortable for some of you, because when you're solving, again, a lot of you realize you might have some difficulties with the reverse bedmass. So before we begin, I actually like doing a substitution for this part. And let's just break this up so it's different. Let theta equal 4t minus 10. And I'll explain that in a moment. Let me just take an extra step so to show you what I'm doing. So what we have is 3.2 is equal to 5 cosine theta plus 6. Now you don't have to do this, but I think for the teaching purposes, I think it will help. So what are we going to do first? According to solving, we should subtract first. Not deal with that 5, but deal with that 6. So I'll subtract 6 to both sides, and what do we get? We get negative 2.8 equals 5 times cosine theta. What do we do next? I think everyone agrees. Divide both sides by 5. So we get cosine theta is equal to negative 0.56. Now, here's a good time to kind of think about what's happening with trigonometry. That's why I like doing this example, even though it's not in our lesson 4. That's why I did a supplementary. Cosine theta equals this negative ratio. And again, you learn from the unit circle. Where will this angle form? And there's actually two possible angles. One angle there, and one angle there. Now, that's why you're looking at actually at the graph here. We get not one, but we get two answers on our graph. That's why it's easier to see it if we graph it, sketch it. All right, so this angle that we're going to solve for, even though it's not an angle, it's really representing time. You do the inverse cosine. What do you get? 124.055. Jess, that's an extra thing. Do you think you can tell me the related acute angle? I'm going to not let go, let you see if you can solve that, because then you will get your second answer mathematically. But I'm digressing. So once we have theta equals 124.055, we substitute back that 4 times t minus 10. And so what do we get? 4t minus 10 equals this. It's not writing. 124.055. Divide both sides by 4. And let's just do it on the calculator again. I skipped a step, sorry. 124.055 divided by 4. I get t minus 10 equals 31.01375. And then t is equal to 41.01 seconds. So that kind of represents this point. And it kind of makes sense. It's clearly when John is reaching or going down from his maximum to its minimum. It's not writing. 41.0 seconds to reach a height of 3.2 meters. So that's question B. So hopefully you enjoyed that. Hopefully that assisted you. Again, you have on the second page the solution. Unfortunately, you don't have the second question that I just did because they're just asking you to do it. Okay, as always, feel free to pause, review, rewind. You can always email me if you have any questions, and I wish you the best of luck. Have a nice day.